Okay, we'll start with kinship and kin selection, part 3. Let's see. So we've been talking about what kin selection is and given you some examples. Now, when you have a theory like kinship theory or kin selection, you should be able to make predictions based on this theory that pan out, that are supported, right? Emlyn in 1995 decided to make a series of predictions about family dynamics based on kinship theory. Emlyn came up with something like 15 different predictions and subsequently has tested, or other people have tested, these predictions. Davis and Daly tested some of these predictions in humans as well. So I want to give you some examples of a few of these predictions that were made and some research that either supports or doesn't support these predictions. So here's one of the predictions that Emlyn made. He said, family groupings will be unstable and disintegrate when acceptable reproductive opportunities materialize elsewhere. So if you've got a bunch of animals who are cooperatively breeding, if there's a chance to breed on your own somewhere else, they should disband. They should be unstable, they should disintegrate as a family group, and each individual should be out for itself, right? So each animal should maximize its own reproductive fitness. So if it can breed successfully on its own, it should leave home. If it can't successfully breed on its own, it should stay and help, increasing its inclusive fitness, right? That's where you get the cooperation. All right, well, Pruitt, Jones, and Lewis in the 1990s studied the superb fairy wren. This is a tiny little bird that lives in Australia, and this little bird has cooperative breeding. The young males help at the nest. So after the males and females are hatched and fledge, females will leave, but males will stay at the nest and help, typically. All right? The question is, will this family break down if there are suitable opportunities to reproduce elsewhere? Now, researchers realized that in this species, females tend to be limited, tend to be a limiting resource for reproduction, and habitat tends to be a very limited resource for reproduction. And so what they did was they experimentally manipulated the availability of territories. And they asked the question, do family groupings stay stable, or do helpers leave the nest when they're given opportunities to breed elsewhere? And here's what they did. They removed breeding males from 29 territories. So basically, a male and a female have a territory in which they breed, and then helpers will help them breed. But there are these different territories. Each territory is owned by a male and a female. What Pruitt, Jones, and Lewis did was remove some of the territory-holding males and ask the question, what do helpers nearby do? Do they stay and help at their parents' nest, or do they leave? And when there's an opportunity, when there's a habitat available for them to take, do they leave? Yeah. They found 33 male non-breeders in the area dispersed to unoccupied territories. And we've got some barking going on. I'm going to let my dogs out here. Sorry about that. And the mean dispersal time was 5.3 hours after a male was removed, a breeding male was removed. They don't waste any time. As soon as they are given an opportunity to breed somewhere else, boom, they're on it. So helping cooperation happens when there's no better opportunity, so to speak. What about humans? Well, Daly and Daly found that newlyweds are more likely to leave home than single, same-aged siblings. This is no surprise. We probably knew this. So that would support the idea that when there's opportunities elsewhere, then you should leave home. But here's something. Newlyweds are at least as likely to remain in contact with their parents, their siblings, their grandparents, as are single children who have left home. So that the family grouping isn't disintegrating or being unstabilized by the newlyweds leaving. Why not? Well, this certainly isn't supporting our prediction, but maybe it's because parents and grandparents tend to be post-reproductive helpers. They're going to help that newlywed couple raise their young, right? How many times doesn't a grandparent or a great-grandparent help out with the new baby in the family, right? So it's interesting. Here's prediction number 2. Families that control high-quality resources are likely to be more stable than those with lower-quality resources. In other words, we can get this establishment of dynasties, really powerful, rich families compared to a lot poorer, less powerful families, right? Does this happen in the animal kingdom? Yeah, apparently it does. And a great example of that would be acorn woodpeckers, where a single genetic lineage basically gains control over a given area for many generations. So what are these guys? Acorn woodpeckers are cooperative breeders. Lots of cooperative breeders. This might be something that interests you for your cooperation project. They live in southwest United States down to Colombia. They live in large groups made up of multiple breeders and non-breeding helpers. So you don't just have one pair of breeders here. You have lots of breeders and lots of helpers in this giant group. And what they do is they collect acorns and store them. So they make a bunch of holes in their granary, if you will, and they collect acorns and store them in those holes, and then they use them. I would love to see these acorn woodpeckers sometime, right? And how fun would it be to go to a granary? And there's a nice video here that you should check out just for fun to see what those granaries look like. And if you have a good territory, you have an enormous granary with maybe 3,000 or more acorns stored there. And so that means you must have a lot of oak trees. You must have a big granary with lots of holes to store all your acorns as well. That's probably been around for a while, right? And been used and recycled over and over. Or you could have a really poor territory. And it might have fewer than 1,000 acorns in a granary, and it's smaller. It has less oak trees, etc., etc. So we've got different kinds of territories. The question is, do individuals on better territories produce more offspring? Do they survive at higher rates, right? Do birds from high-quality territories stay at home and help more than birds from low-quality territories? Well, being on a large territory does mean you're going to survive longer, and you can see that from the graph. But what about staying and helping? That's what our prediction said. If you live on this, if you live on a really rich, high-quality territory, you're more likely to stay at home. In great territories, more than 27% of young stay on their natal ground to help for at least a year. In poor territories, less than 2% of the young stay and help. And it turns out researchers have calculated the lifetime fitness benefits for animals who live on these great territories in these dynasties, and it pays off to stay at home and help for at least 1 year. They have higher lifetime fitness than if they were to disperse to a poor quality territory, because that's basically all that's around when you disperse. So it benefits them to hang out and help and eventually breed later. What about humans? Oh, I don't have anything. Humans. Are well-to-do families more stable than poor ones? Well, co-residence, parents and kids living together, is actually less likely in rich families than in poor families. So that would not be support for this prediction. But there's an increased contact and increased support in wealthier families, even when children have moved away. So wealthier families continue to support their children even when they move away. So this would be support for the hypothesis that families that control high quality resources would be more stable than families that control lower quality resources. So this is kind of equivocal, I guess. Prediction number 3. Here's another prediction. Cooperative breeding will be expressed to the greatest extent between those family members that are the closest genetic relatives. So we would expect close genetic relatives to be more likely to do cooperative breeding than distant genetic relatives. That kind of makes sense, right? Is that what we see? Well, in the research, we actually see this in animals. There are a number of animals that we call eusocial, highly social animals, like bees, wasps, ants. These are all members of an order of insects called the Hymenoptera. It's the third biggest order of insects. And many of the animals, not all, in this group are social insects, and they show intense cooperative breeding. Typically, if you think of, say, a honeybee hive with one queen doing all of the breeding and a bunch of female workers who are not breeding at all. These workers are providing all of the care for the queen and her young, all of the resources for the queen and her young, all of the defense of the queen and her young. This is called a eusocial society, and we're going to talk about eusociality in the next lecture. But the question then is, in these highly cooperatively breeding animal groups, like in honeybees or in certain wasps or ants that have eusocial societies, what is the relatedness of individuals who are participating? Are they closely related? Are they distantly related? We'd expect them to be closely related. And it turns out in a lot of these hymenopterans, hymenopterans have a really unusual way of breeding. Males are haploid, they have one set of genetic information, and females are diploid. And what that means, if you do some of the math, I'm not going to necessarily do this math for you, but you can think about it for a little bit. What it necessarily means is if you have the same father and mother breeding, so the mother is the queen and the father is some haploid drone that happens to breed, the sisters that are produced should be 75% related to each other. They share all the same genetic information from their dad and 25% of the same genetic information from their mom. And so they have 75% of the genetic information should be identical to each other. And you can probably see then that we would predict in these insects a high level of cooperation or altruism because they're so closely related. And we do see a lot of these eusocial societies showing up in the hymenopteran insects. Now, they're not showing up in, not all hymenopteran insects show high levels of altruism or cooperation. Not all eusocial animals are in this group and have this kind of inheritance pattern. We have mammals, for example, called the naked mole rats, who have just a regular sexual reproduction like we do, and they're eusocial. But this is really an interesting prediction that pans out in the hymenopteran group as a whole. Okay, we'll look at conflict in animals in the next video.